Okay, so exam 2 review, right? The review for exam 2, question 28. It's what's the enthalpy change for this reaction? Okay, so this question here, you have the main reaction, and then the question gives to another reaction. So when you have like the reaction, and the only thing given is another 2 or 3 reactions, you are going to solve the question using Hess law. You are going to manipulate these 2 reactions to adapt them to make sure you have the global reactions. Like this reaction is like the box that you needed to make these 2 reactions to be like this one. Okay, how are we gonna do this? Right? So we need to check one by one. Right. So here, iodine fluoride plus fluoride gas, right? And making iodine trifluoride, and you have the enthalpy change. Let's say this one is reaction 1. The reaction 2, you have also iodine fluoride and 2F2, and then iodine pentafluoride, and then the enthalpy change here. So let's compare these 2 reactions with this one. So IF, iodine fluoride here, do not have the main reaction, right? So you need at some point we need to cancel out here. Okay, so then F2, we have in the reactants and we have in the products. So for now, let's keep this first reaction as it is. And here, iodine fluoride is in the products. And here in the main reaction, the global reaction is also in the products. Let's see, for now, let's not do anything with reaction 1, right? Okay, let's go ahead here and compare with reaction 2. Reaction 2, you have iodine fluoride here, all right? I have 2 fluorines, 2F2 here. And here you have iodine pentafluoride in the products, right? And right here in the main reaction, the global reaction, iodine pentafluoride is in the reactant, is in the product. That it means this IF5 should be in the reactant. So how are we going to do what we need to do here? We need to flip this reaction. And how we can flip? We need to multiply all the reaction by -1. So everything that is products will become reactants, and everything that's reactant will become products. So I'm gonna just flip it here. So IF5 right here now was a product, now will be a reactant. Then iodine IF here was a reactant here, and now will be a product plus. Okay, so no. 2F2 here was a reactant, so now it will be a product, right? So now we already used this equation, we flipped everything, right? And I will see where it said it shows minus should be now positive, right? Okay, so now let's adapt the first reaction with the new second reaction here. Let's see what you can cancel out to get the global equation here. Okay, let's check one by one. So now you are going to compare reaction one. Now we're going to adapt, right? Reaction one with this reaction two, the new reaction two, because we had to flip, right? Okay, so IF gas, he is in the reactant side and he is in the product. And when you look at the main reaction, we do not need iodine. All right? So let's cancel out here because they are the same thing in opposite sides. One in the reactant and another in the product, right? Okay, so you are done with IF here, okay? Now, the next is F2. So here you have one F2 gas, right? And now you have a 2F2 gas. When you look in the main reaction, you need F2, but you need just one and in the product side, right? So that it means one cancel with one here. So we still have F2 in the product. That's exactly what you need, right? So what you need exactly is F2. So let's repeat the F2 here. What else do we need here? Iodine, fluoride, trifluoride, you have it here in the product. And you do not have any place to cancel out. That means just repeat here. So we're going to repeat here. Iodine, trifluoride here, right? That is get the same, right? It's getting close here. Close. All right, and then the next is, so now you transfer here. The next one is in the second reaction after you flip, right? You have I pentafluoride, and you do not have anything else to cancel out. So just repeat here. So now let's compare. Is this reaction the same as this one? IF5, yes. Right? That's react. In the products, you have IF3 and F2. That's correct. Now you got the same reaction. We just played with these two reactions, adding up to make the final one. And the only thing that we had to do here was multiplying, right? This reaction 2 by -1. Now let's go to the math. The reaction 1 was -390, right? That did not do anything reaction 1. And what did we do? What did we do? What happened to reaction 2? We multiply by -1, right? So the number that was negative now is positive, correct? So let's now take plus 745 kilojoules. Right now, you are going to make the math here. Minus 390 plus 745, and then you can find your answer right here. All right, okay. Now, reaction, this here is about Hess law, how to solve equation using Hess law. But I'm going to use a Hess law when you have the main reaction, and then the question gives 2 or 3 another reactions, because we needed to add up these reactions to make the same as the main reaction, right? So now question 29 is chapter 4, that's about balance and determine what is oxidized and what is reduced in each reaction. Assign the oxidation number of each element. So we needed to review about oxidation numbers, right? What we have initially. The oxidation, let's now assign everything here first. Okay, let's start here with zinc. Zinc is just a zinc, solid. It's only by itself. There is no charge, so the oxidation number is 0. So everything that just by itself, right, the oxidation number will be 0. The same thing here and here, right? Now, what's the oxidation number for the copper thiosulfide? So thiosulfate here. So oxygen is usually a -2, right? And this compound here is a copper thiosulfate. So the oxidation number here will be a +2. All right, so the same thing here. Zinc sulfate, zinc, and you're gonna be the same thing here. So he will be a +2, and he will be a -2 for oxygen. Next to this, the sulfate here, but all the sulfate, right, is a -2. And this is why we can figure out that the metals here will be a +2, because actually the sulfate ion, all the sulfate ion, right, is a -2 here. That's why we already knew that the copper will be 2 and zinc here will be 2. Okay, but we can also figure out doing one by one. I will show here in the zinc chloride. Okay, so we assign the oxidation number of each element. Not yet. I did not assign the sulfur, right? Let's see here what they're going to be for sulfur. So copper thiosulfate here, right? There is no net charge in the total, so let's call it 0, right? Copper just have 1 copper, so 1 times 2 will be +2. Sulfur, we do not know yet. Let's call X plus X. And then we have 4 oxygens, right? And each oxygen is a -2. 4 times -2 will be a -8, right? So when you rearrange here to solve for X, will be a +6, right? So the oxidation number for sulfur here is a +6. The same thing will happen here. So the math will be exactly the same actually, right? Because -2 and a +2. So you know that the sulfur here is also +6. Okay, we assign oxidation number of each element, right? But the question is, which one is oxidizing and which one is reduced? So we are going to track the oxidation number. The element that it changed the oxidation number will be the ones that will be oxidizing or reducing. Let's go with copper. Copper here was a 2+, and here's what? Is a 0, right? Let's track here. Was a 2+, and now it's a 0. The oxidation number, right? The oxidation number decreased. When the oxidation number decreased, that means the oxidation number reduced. So that means you have here reduction. What's reduction? Reduction is gain of electrons. What? But why did the number decrease if it's gaining electrons? So remember, electrons are negative charges, right? So if it's gaining electrons, the oxidation number will decrease. That means copper is reduced. So copper is reduced. The question is asked, right? Which one? So now let's track the zinc. Okay, sulfur was +6 did not change. Oxygen also did not change here, but zinc also changed. It was from 0 to +2. So when the oxidation here from 0 to +2, the oxidation number increased, right? So when the oxidation number increases, we have oxidation. In oxidation is what? Oil. Oxidation is loss of electrons. So when the oxidation number increases, we have oxidation. And when the oxidation number decreases, we have a reduction. That means the answer here could be zinc is here oxidizing. Right? The same thing here, little b. Hydrochloric acid react with zinc metal will make zinc chloride and hydrogen gas. So the chlorine is a halogen, right? 7A, the group 17, 7A. So it will be usually be a oxidation number will be a -1. And the hydrogen is usually a +1. I talk here about the oxidation number rules, right? Okay. Oxidation number 4, zinc is a 0 because it's just the elemental form of zinc, right? And then zinc chloride. We have zinc, we're going to be zinc. We'll have each chlorine is a -1. -1 times 2 will be a -2. That means you need a +2 here for zinc to make the net charge 0, right? +2 -2, so the total here will be a 0. Okay, so now let's see which one changed. The hydrogen changed the oxidation number. Yes, right? Change it from +1 to 0. Did the oxidation number increase or decrease? From +1 to 0, oxidation number decreases, right? If the oxidation number decreases, we have reduction. So reduction for hydrogen, right? Okay, now let's track the another one. Chlorine, here's a -1, is -1, so chlorine did not change. What else? What another element that did change here? The oxidation number. zinc changed from 0 to plus, right? If zinc changes from 0 to plus 2, the oxidation number increased, right? The oxidation number increased, we have oxidation. So the zinc here was also oxidized and the hydrogen was reduced here. Okay, now let's go for question 30 here. So calculate, question 30 is about chapter 4, like question 29 was also about also about chapter 4. So calculate the molarity of the following solutions and their ions, right? So this question here is already answered, so you can get practice. 20.8 grams of sodium hydroxide is dissolved in water to make 500 milliliters of solution. What we have here? The final volume, the total volume of the solution is 500 milliliters, right? What else do you need for molarity? Molarity, you need the moles of the solute. So how can you guys calculate moles? Moles is mass divided by molar mass, right? Moles is mass divided by molar mass. What's the mass here? 20.8 grams divided by molar mass. What's the molar mass of sodium hydroxide? Go to the periodic table. Sodium is at 23. Oxygen is 16. I'm around the number just to be easy. And hydrogen is around 1. So let's say that the sodium hydroxide, the molar mass for sodium hydroxide is, let's around reach 40 grams per mole. Okay, so for here, grams per mole. Okay, now let's divide here, right? 20.8 divided by 4 grams per mole. So here we have 0.52 moles of solute, right? The solute here is sodium hydroxide. So now to calculate the molarity, right? It is moles divided by the volume in liters. What was the moles you guys got here? 0.52 moles, right? Divided by the volume in liters, 500 milliliters, divided by 1,000 will be 0.500 liters, right? 0.500 liters. When you do this division here, your answer will be 1.04 molar. So this answer here is the answer of the solutions. But the question also asks for their ions. Okay, let's see here. Sodium hydroxide. The formula you have just one sodium and one hydroxide. That means the concentration for the ion sodium is 1.04. Hydroxide is also 1.04 molar because you just have one ion of each one. Sodium and hydroxide. I'm going to answer question C so you guys can see why is different here. So So let's get here, right? You need the molarity formula, right? And then moles. What's the formula for moles? Moles is mass, right? Divided by molar mass. So what's the molar mass of calcium nitrate? So calcium nitrate molar mass. Okay, let's go here. The mass given, 32 grams calcium nitrate, and the molar mass was 164.08 grams per mole, right? Let's do this division here. To find the moles, it's going to be 32 divided by 164.08. So it will be 0.195 moles of calcium nitrate, right? So I sometimes get a little blurry. Okay, right? So let's get this number. This mole here, 0.195 moles of calcium nitrate divided by volume of the solution in liters, right? Liter divided by 1,000, so 352 divided by 1,000 will be 0.352 liters. Okay, let's divide this by 0.32 is equal to 0.609 molar of calcium nitrate. Calcium nitrate. So this portion here, right, only answer the solution, the concentration for the solution, for the compound. But the question asks for the ions. So the ions here. How many calciums do we have here? Only one. So the concentration, let's answer here. The concentration for calcium, so we have only one calcium here, which will be the same, 0.609 molar. And now the concentration for the nitrate. Oh, the brackets here, the brackets in concentration. So how many nitrates we have in the formula here? 2. So going to be 2 times 0.609 molar, right? And then you can calculate it here. So that means nitrate, calcium nitrate, the molarity is 0.609 molar. The molarity of the calcium ion is 0.609 molar because we have just one calcium here. And the ion, the nitrate ion, we're going to multiply this by 2. So we're going to be by 1.22 molar. So in another words, if you have a question asking to calculate the ion, the concentration for the ions, you need to check how many ions you have in the formula. Here, 2 nitrates. The nitrates, this portion here. So I have to multiply by 2. Okay? Right? Okay. So, question 1 is about precipitation. So, you need to go back to, so you can use the solubility rules, right? The exam. So, you need to check it here. For example, right? silver nitrate with potassium chloride. So what are going to be the product? So first let's change here double replacement, right? Silver is with nitrate, now will be with chlorine, right? It will be also going to be like positive, negative, positive, negative, positive, negative, positive, negative, right? Always the positive, the cation, the positive will come first, and then the second will be the negative, always. That's the anion. So silver now will be with chlorine, and potassium now will be with nitrate. I've seen here what happened. So the new equation, the molecular equation is this one. So A equals, but as here you have for silver chloride, you have a S. Right, you have S for silver chlorides. So all halides are soluble. Like halogens is a halide. Chloride is a halide, like here. They are soluble except when you're with silver, mercury, or lead. That means when you have a silver with chlorine, it will be solid. That's why here it is showing S for solid. So this is the molecular equation. And then check if everything is balanced. One silver, nitrate, potassium, 1, chlorine, 1. Okay. Now let's go to the second step. The second step is the total ionic equation. The total ionic equation, we're going to dissociate everything that is in aqueous. But what is solid will stick together. So here, silver nitrate, dissociate here. Silver plus, nitrate minus. I see here, they are separated now. Now, potassium chloride. So now we have potassium plus chloride ion separated here. Then, now the products, right? Silver chloride is solid, so we'll continue together. And potassium nitrate is equal, so we'll dissociate it here. We'll separate it, right? Okay, so now the next step is to cancel everything that's the same in opposite sides, like here. Silver here is a plus, here is not. So silver here is all by itself, right? In equals, but here is a product, right? Is a solid. That means here we cannot cancel silver. Nitrate here, nitrate 3 minus and equals, and here, if you look at the two, right? Exactly the same. So yes, you can cancel out. It's exactly the same in opposite sides. It means one the reactant and another in the product. Now the same thing for potassium plus right here, exactly the same. So yes, you can cancel out here. The chlorine here, right? Chloride ion is aqueous, and here it's as a solid. So no, we cannot cancel out silver and we cannot cancel out chlorine. So the net ionic, the step that it shows the ones that did not cancel out. We did not cancel out silver, did not cancel out chlorine, right? So the ones that we canceled out here, we call them spectator ions because they are only watching, they are not reacting. That's why they did not change. But silver and chlorine did change. So this step here is really shows the reaction happening here. Right? So you need to pay attention with the solubility rule first to be able to write all 3 steps. Right, so here, I'm gonna show letter E. So hydrochloric, this one will be a little bit different because this one here is a strong acid and a strong base. It's still gonna be the same step, but still be solid, now will be liquid. Okay, the same thing, hydrochloric acid, sodium hydroxide. So sodium is the positive here, and now will be the chlorine that's negative. Sodium chloride equals. And then H plus OH, you have water. That's liquid. So when you have a strong acid and a strong base, it's a neutralization reaction and it will produce sodium, salt and water. In that case here, sodium chloride and water. So this step here is called the molecular equation, right? What's the next step here? Will be total ionic equation, right? Let's do here. So let's associate everything except that's in aqueous, right? So hydrochloric acid. Before check the reaction is balanced, right? Two chlorines. Oh, sorry, two hydrogens, two hydrogens. One chlorine, one sodium. So yes, it's okay, right? Now let's dissociate everything that's in aqueous. Hydrochloric acid, H plus chlorine, right? Plus sodium, plus, right, ion, equals, then plus OH, hydroxide. The same thing here. Sodium chloride, sodium plus equals plus chloride ion plus water, liquid. Okay, now we're going to do the same thing. Oh, by the way, this equation here is called the total ionic equation, right? That is show all ions, that is everything that is in aqueous will be converted to ions. And if it's liquid or solid here, we're going to continue here together, right? All right. Okay, now let's cancel what is exactly the same. H plus by equals, no, he is not the same, so cannot cancel out. Cl minus equals, so yes, let's cancel out here. What else can you cancel out? Sodium, ion, and exactly here, right, the same way. So yes, we can cancel out. Now, what's the net ionic equation here? The net ionic equation, right, will be everything that you did not cancel out. Everything that does not have spectator ions. Spectator ions are the ions that we cancel out because they are not reacting, they are not changing. So the net ionic equation is the step that really show the reaction, the step of the reaction, right? Do not cancel H plus and hydroxide ion, right? And here did not cancel the water. Oops. H2O liquid, right? So the net ionic equation show the step, the reaction step. All right? Okay. We're going to do the same thing for C and D, right? pay attention with the number, the solubility rules here. For example, see magnesium nitrate and sodium carbonate. So we're gonna have like magnesium gonna be with the carbonate and the sodium gonna be with the nitrate, right? So like, we're gonna get here magnesium. Magnesium is a 2 plus. And carbonate is a 2 minus. So you do not need to put the parentheses here because it's already plus 2 and minus 2. Why magnesium nitrate is a 2? Because each magnesium is a minus, right? And then each magnesium is a minus 1, so that's why you need 2, oh sorry, each nitrate is a minus 1. That's why for magnesium nitrate, you needed 2 nitrates. But magnesium carbonate is already 2, 2. Then, sorry, magnesium carbonate will be what here? Now let's go to the rule is here. All carbonates, phosphates, oxalates are usually insoluble, right? Except when they are group 1 or ammonium. So carbonate here is what? Magnesium carbonate. Carbonate will be solid, insoluble or soluble. So here it will be S for solid because the carbonates are usually insoluble except when you have like a group 1. But magnesium is a group 2. If it's a group 2, will be precipitation. That means it will be solid. Magnesium carbonate will be solid. Now, the next we have is sodium and nitrate. Sodium nitrate, right? What it says about sodium nitrate? All nitrates are what? Soluble. That means sodium nitrate is soluble. If it's soluble, will be aqueous. Right? Okay. Then, right, okay. Now let's balance. You need to balance, right? One magnesium, one magnesium. Okay. 2 nitrates, 1 nitrate here. Let's add it. 2 nitrates in front. Sodium have a 2. Now also have a 2. Carbonate 1, carbonate 1. So yeah. Now this equation is balanced here. This is the molecular equation, right? The next is the total ionic equation. Total ionic equation. Now let's associate everything that is equals, and let's keep together what is solid, right? Okay, so magnesium 2 plus equals. How many nitrates do you have here? 2 nitrates. And each nitrate is a minus 1. Plus, let me just pause here a little bit. I'm really hearing a noise. Okay, all right, let's continue here. We dissociate nitrate. Now, sodium carbonate. You have 2 sodiums here, so this sodium will be before 2 sodiums. Each sodium is a plus 1. Because sodium is a group element group 1. Okay. Oh, by the way, this one here, sodium carbonate, this one here, sodium carbonate is equals because sodium is a group 1 element, right? That's why here is aqueous. But magnesium carbonate, it's solid because magnesium group 2A. It's not a 1. Let's continue here. Plus 1 carbonate equals, right? Magnesium carbonate with solid stick together, right? Do not dissociate. So just repeat it as it is. Magnesium carbonate solid for the products, and then associate here to sodium plus and to nitrate. Plus 2 sodium plus equals and 2 nitrate equals, right? Okay, this is the total ionic equation. We still need to write the net ionic equation. The net ionic equation, the one that it shows only the elements that it did react. So here's a 2 minus here, right? Okay, so let's do here. Did magnesium change? He's a 2 plus and he is with carbonate. So yeah. So no, we cannot cancel out magnesium. 2 nitrates, 2NO3 minus, the reactant, and he's in the product. Exactly the same thing. So yes, we can cancel out. Sodium, 2 sodium plus. Here, 2 sodium plus. Exactly the same thing. Yes, then we can cancel out, right? Now, the net ionic equation, the step that shows the one that will show the one that did not cancel out. Magnesium 2 plus do not cancel, right? Carbonate plus carbonate do not cancel out, right? In magnesium carbonate, that's one that is solid. Right? The net ionic equation does not show the spectator ions. Spectator ions are the ions that you were canceled out because they're only watching, right? Okay. All right. So question 31, oh sorry, 32 is about oxidation numbers. For example, for sulfuric acid, he shows the oxidation number for sulfur is a +6. You need to do all the math to find the answer. Okay, so first thing was the oxidation number for oxygen here. Oxygen is an element, is in its elemental form or all by itself, so it's 0. All element, all is just by itself, without charge, that's the element, the elemental form would be oxidation number is 0, right? Now, sulfate ion. The ion here has a charge, right? That means this one, it's not equal to 0. Here's equal to -2. And sulfur, we do not know, let's call X. And oxygen, when oxygen is in a molecule, or a compound, or any species, oxidation number for oxygen is usually -2. Now let's do the math here. Sulfur, we don't know, let's call X. -2 times 4, -8. Now you do the math here, right? +8 -2. So oxidation number for sulfur will be a +6. Here. Oops. Right? And what else? What's the oxidation number in hydrogen peroxide? Hydrogen peroxide will have an exception. So H2O2. Hydrogen is usually what? +1. Oxygen is usually -2, except in a peroxide. If it's in a peroxide, it will be a -1. And even if you do not remember the exception, if you do the math here, that the net total charge should be 0, you would know that in hydrogen peroxide, oxygen will be -1. Because +2 minus 2 equal to 0. Okay, so let's see the next one. Question 32 is about a titration. Oh, sorry, question 33 is about titration. I'm going to stop here this portion and then do a different video.